Hey, so my name is Peter. I'm a product manager here at Sensolus. So you're a go-to point for all your product and roadmap related questions.
Hi, I'm Jeremy. I'm responsible for customer success at Sensolus. So many Sensolus customers use the Sensolus solution to track assets within their supply chain to create visibility within the logistic flows. The assets they track can be different types, can be returnable packaging, boxes, pallets, etc. One of the specific things within this use case is that assets travel both inside buildings, at the assembly lines, for example, as well as outside. When they travel from a supplier to the assembly lines, they can be on a parking lot or in a truck during transport. So when tracking assets indoor and outdoor, different geolocation technologies need to be combined. So Sensolus has a lot of experiences in that, and Peter is going to explain us how this works, because when we think about tracking, we think about GPS. So tell us a bit more about how GPS works and what the challenges are of using GPS within this use case.
Okay, so it's a very first question typically that people have when it comes to asset tracking, right? And people talk about GPS and we compare it with the things that we are used to, right? So we compare it to our phone and we think it has GPS, and we are inside and we see still location. So we think GPS works inside, right? But contrary to that basic assumption, this is not really working.
Okay.
Right? So GPS does not work indoors when you have ceilings, roofs, especially thick roofs. It doesn't work indoors. But how is it possible then that we still see locations when we are on our phone, when you are in a building and a shop, you can see your pointer actually moving around? This is because this is actually a very smart thing, and it uses a lot of different location technologies. Okay. So when it does not have the GPS functionality available, it will switch automatically to, for example, Wi-Fi sniffing localization or GeoBeacon, Bluetooth GeoBeacon localization. So quite some technicalities, but just do not compare with your smartphone, right? Initially, when you think only about GPS. People also, we have sport watches. There you might start noticing it.
Okay.
If you run, most sport watches are only GPS. If you run, like for example, below a bridge, you will see that your speed is suddenly very inaccurate. You're running faster or slower. That's because actually the GPS signals bounce on the bridge and your location is suddenly very inaccurate, right? So how does our tracker compare to this? For example, Sensolus tracker is actually also a very smart device. So you could put it more to the side of the smartphone. It's a smart tracker, and it will use different location technologies when it's inside compared to when it's outside. So when things are moving outside and they have a very good view of the sky, we use GPS. Automatically, when this is inside and it will detect I'm inside, it will detect I do not have sufficient GPS strength, then it will, for example, fall back to listening which Wi-Fi networks are available and then send that to our cloud platform, and you get still a location inside. GeoBeacons are similar. You can have signals that are emitted, a bit like when you drive with your car in a tunnel. Then you also still see you are progressing. GPS is not working in a tunnel, but the governments and the people who maintain the tunnels, they are placing actually small signals, GeoBeacons that emit a signal, and still your car can then, progress its position inside the tunnel. Yeah.
Right. But of course, the best tracker is one that can combine different geolocation technologies, like in industrial manufacturing. That's a typical example where assets are indoor and outdoor. Can you give some examples of these work processes, these workflows?
Yeah, indeed. So typically, you want to start tracking returnable transport packaging, which means that, so these are containers, jigs, or whatever that contains something valuable, right? And typically this travels from outer locations. For example, it could go to a supplier and come back, but it's not exclusively outdoor, right? When it arrives at the supplier, it will typically be put on a parking lot, and then it will be inside. You still want to have visibility where something is when it's inside with your supplier. And then it comes back to the main manufacturing site, Can also be first place outside. You want to have visibility while it's being transported per ship, per train, per truck to you. And then typically it will be stored inside at one point. It can be in a temporary storage space, it can be in a stock space, and then it moves into even the manufacturing process. So even inside a big factory hall, you need to have visibility because you want to detect more or less with some zonal precision where is it, so you can still retrieve it in your process.
So you know how many boxes are empty and which ones are ready for departure.
Exactly.
You can make these different inventories.
Yes, exactly. Because so typically in industrial manufacturing, people already have the habits that they have specific spaces that correspond to certain steps in the process.
Makes sense.
Right? So the things that are stored at this specific location mean that they are in this part of the inbound or the outbound or in the processing step.
Okay.
Yeah.
And so I assume, and you talked about geobeacons, but placing geobeacons everywhere isn't easy if you don't control all the places. So what are the other solutions?
Yeah, so typically the most easy and useful fallback for inside location tracking is to use Wi-Fi sniffing.
Okay.
This means that the tracker will detect the strongest Wi-Fi signal. It's like a unique fingerprint, really like a fingerprint that we have. And by that, because this is unique, you can know where it is. That's because other companies, other providing services have mapped out where these Wi-Fi routers are.
Okay.
And that's what used for localization. That's very good and definitely works at your suppliers. You would then, if you would need more precision, because sometimes the range is very high, leading to not so good precision indoors. If you want to increase your precision to get to more like zonal information that are more close to each other, then it's good to place some geobeacons. But these are actually quite cheap devices,
Okay.
easy to place, they have a long battery life, and it's far more advantageous to just use these. It's not a lot of effort. You install this compared to other indoor localization technologies, which are often, which are cabled, which require network access and require a lot of maintenance.
Okay. And can you give like a ballpark figure on accuracy with Wi-Fi versus Bluetooth?
Yeah, I think with Wi-Fi, I would say 50 up to 100 meters. With geobeacons, if you position them well, you can reduce this below the 50 meter, going up to, let's say, 20 meters, right? It's not an absolute number that you can give. It depends on situations. It also depends, are there like some walls between, so some things that can block the signal to to keep the zones apart. But definitely this is possible. We should not give the impression that you go below 20 meters, or Bluetooth signals for this type of location are not giving you 3 meter or 1 meter precision, right? But if you keep things reasonably separated, Bluetooth geobeacons are really a good solution.
Okay. And how does a tracker know what to use? How does a tracker know I'm indoor, I'm outdoor, or I need Wi-Fi?
Very good question. And we actually have two solutions for that. One is on the smartness of the tracker itself, and on the other hand, you also have the assumptions that you can make on how the things travel. For example, what I mean with this, you can configure this tracker to try first a GPS fix, and if it then detects, I'm not seeing enough satellites, then it falls back to, for example, Wi-Fi or geobeacon.
Okay.
Both steps use some energy, so they cost you a little bit of battery life. But of course, you can know if I have mostly locations where geobeacons are there, then I would configure the tracker remotely. First try geobeacons, and only if that fails, you do Wi-Fi. On the other hand, if you know that this is mostly traveling to locations, to suppliers where I do not have geobeacons inside, we will configure it the opposite way, right?
Okay.
Also, if this would be mostly indoor and occasionally park outdoors, we would configure this tracker to only to first try the indoor localization technologies and then the GPS. The good thing is that this is all remotely configurable, because think about it, when you start tracking, the typical thing is that often you still do not know how exactly this is being used. So this means that you start deploying the solution, then you see the patterns, and typically people are surprised because the reality does not match, what they thought was happening, exactly the reason why people start tracking. And then with with the tools, the remote sensing tools, and also supported by several other things like energy consumption, battery estimation, and by customer success teams of Sensolus, we can together reapply a different configuration so you have either a more prolonged battery life, or with the same budget of battery life, have more locations and a more timely response in your tracking solution.
So if I can summarize, it's smartness in how you configure the different technologies on the tracker and map that to the specifics of the use case.
Exactly, yeah. And also adapt as you grow, adapt as you learn.
Okay.
Right? So it's not a one-off thing, really important. You need this remote growing and learning curve. You need to serve that wave, and then you get the best results.
All right. Another question is, you talk about combining all of these technologies. I assume that in these use cases, it's consuming a hell lot of energy. So these batteries, they won't last for 4 or 5 years. Or how does Sensolus manage this? That within this context, complex technologies, you still reach the battery autonomy that you need?
Yeah. So very good question. So we have several strategies, but let's maybe compare again our devices that we have in terms of what means battery life, right? So in absolute terms, this phone even has a larger battery than this tracker, right? But this phone does a lot, uses a lot of energy, but I'm perfectly fine with recharging it every day, or even multiple times per day, and I might even carry a battery pack, to just recharge it while I'm on the move. Here, the expectation is I want to deploy this on my assets once and have peace of mind for the next 5 years, right? Because replacing this is a hassle that requires people, requires organization. That's a cost you don't want to have, right? So a very big difference how much you recharge it, right? And we can also, for example, my sports watch, I'm perfectly fine with every 2 weeks recharging it.
Okay.
With medium use, that's good. So how do we do it then that we still have 5 years with also GPS tracking and a lot of smart localization technologies, right? First difference is people should realize that you cannot have the same responsivity that you have with your GPS and your smartwatch, which do, for example, a new location point every 5 seconds. Here we will need to make some compromise and we need to be a bit smarter. So first thing is, this one has an accelerometer, so it will detect when it is not being used, when the asset is not being transported. Of course, the tracker can be very smart and say, I will only, for example, every 24 hours send you a location message. That's a very energy consuming step to take. Secondly, when it knows it is moving while it is still vibrating, right, we will have a configurable interval of sending location updates. This can be adapted to the use case. For some cases, you would only need every hour. For some more intensive use cases, you would need this every 10 minutes, for example. These are all different things. Or you could also say, when I start moving, especially then, I want to have more location points, because it's often useful to know exactly when it has left the factory, right? We also have some things very soon available on our roadmap that we are working on, even to map then when you're going somewhere, a destination, that you could also increase the frequency and the responsivity. So responsivity is very important, and we are as smart as we can to dynamically adapt this responsivity because the responsivity drives the energy usage.
All right, thank you. So Peter, you mentioned the different geolocation technologies. Can you maybe one more time go over them one by one, and also tell us what happens if none of them work in the end? You don't have GPS, you don't find anything indoor?
Yeah, okay, good. So let's start with the common one again, GPS. GPS, everybody knows GPS. To be technically correct, you would need to say GNSS, Global Network Satellite Services, right? Because GPS is the American system. Then we have Galileo, the European system, Baidu, the Chinese system, and forgot the name, the Russians also have. GLONASS have also their system, right? Trackers can use often different satellites together, by the way, to locate. The thing is these satellites are sending signals, and the chip in the tracker can determine based on these signals, can determine a latitude and a longitude being coordinates of the position on Earth.
Okay.
Yeah. And a second technology that we have is, which works great on many places, is Wi-Fi sniffing, Wi-Fi localization. What does this mean? It means that people are installing routers all over the place in industrial and into urban environments because we all like to have Wi-Fi. Now, every Wi-Fi router, every Wi-Fi gateway has a unique number, a MAC address it's called.
Okay.
You could consider that a fingerprint, and it's unique global. So that means if you scan this and if you know where this Wi-Fi router is, then the tracker can just say, I'm close to this unique fingerprint, and then you resolve, but this is done on the cloud platform, you resolve where are you. Right?
Okay.
Or it can say, I'm close to these three, and then have even a better location.
So just to be sure, the tracker does not connect to the Wi-Fi network. It doesn't need
tracker,
a password.
very typical, a very good question. Typically, many people ask it. You don't connect, so there is no connection. It's just sniffing. Right?
Okay.
It's not connection. You don't need to know the password at all.
All right.
Also mean it doesn't connect to a corporate network. There's no active connection. There's not any possibility of sharing data.
All right.
Yeah. Very important is how does this work? It's different companies that specialize on that. You might have seen sometimes, a car of Google driving through the streets. They are not only, taking pictures for street view, but they're also scanning where these Wi-Fi networks are. And typically, people do not move their routers also, right?
Makes sense.
That's how that works. So good. Then the third very common location technology that we can use is geobeacons. This is actually, you can use such a simple device, and it has some batteries. It lasts several years. You mount it somewhere on the wall, and this is emitting Bluetooth signals, just a ping. It's just emitting a ping, but also with a unique fingerprint, just like with Wi-Fi, but now it's just Bluetooth based. This is a lot cheaper than a Wi-Fi router. It also has a lot less functionality, but it just serves then to give a unique fingerprint in the area, let's say in 50 meters radius, where which unique geobeacon there is. And then, since this is not serviced by other companies, in the Sensolus platform you say this geobeacon with this serial number is positioned there.
Okay.
And then our platform, without external services, can actually say this tracker must be there.
Okay, but so you need to install some devices, but it looks really simple. You don't need to cable or anything.
Exactly, and that's why we call this light infrastructure, right? Okay. There is a little bit of work, but it's not as complicated as installing new cables, power lines, network cables, right? Which is something which, if you would only have Wi-Fi and you would just need to add a Wi-Fi router to increase your location precision, that would be already a lot of effort.
Okay,
right?
Makes sense.
We have different segments in which we operate, and all have their unique challenges, right? So in some segments, for example, might be less IT specialized, and there you do not have access to a large set of very specialized IT people that could help you install infrastructure. If you're in industrial environments, there's plenty of engineers running around, but then you are in controlled environments, in factories. Even just installing an extra power line is a lot of effort, which might need approval, which might need special insurance when the electrician comes to install the next cable. So these are all things that you don't want.
Okay.
So when you're a logistical operator and you want to improve the accuracy somewhere, it's really handy just to stick this on the wall, stick this on the ceiling, increase your accuracy, and that will be allowed by the IT departments, and you will not have exorbitant costs associated with installation.
So assume worst case, your tracker's indoor, there's no GPS, doesn't find any geobeacons, Wi-Fi sniffing fails. What happens then?
Exactly. So there is one last resort.
All right.
This is cell tower localization. We also call it network localization because this makes use of the cellular network.
Okay.
Now there is also one misconception. People think a lot that is like, because we all have seen, nice crime movies, and then keep him talking for 30 more seconds, and then we will know exactly where he is, and then you see this pointer like, oh yes, he's in this building. So it is completely non-existing, by the way. First of all, if you want to do triangulation, you would need to keep your connection open for a very long time, as they indeed say in the movies, but that would just drain your batteries too much. So we do not do this with GPS tracking. We will not triangulate different positions. And secondly, so instead we will, for example, say I am close to this cell tower, and then you know in which cell tower you are. But the resolution, the accuracy of this is, let's say, a few kilometers.
Okay.
Yeah, which is good to know in which city or in which village you are. It's also like a very energy efficient location technology, but in general, it's hard for people also to, to live with that, because, you still see a large circle. It might be in here. Intuitively, you think it's in the center, but it might actually be anywhere. But if you want to have very high level, like fallback of location, it's still a very good thing to have.
So it's like in 99% of the cases, your first technologies solve the case. If that fails, you still have in which city I am.
Yeah. Exactly. Okay. It's a good fallback as a last resort. Yeah.
All right. Thank you, Peter.
Yes.
So now you've explained the different technologies. You said something about the accuracy that we can expect. But what if I really need very accurate precisions in, let's say, one part of my manufacturing process?
Yes. Okay. So we do have some solutions for that. Even now, we must be very transparent and very fair. There's a lot of location technology, and especially if you go into the indoor localization technology sector. If you want really high precision, there are solutions that can give you real-time, below meter precision into a factory environment. Now, it has two big disadvantages.
Okay.
First of all, it will have a very significant price tag, and being in license cost and cost to operate, and also in cost of installation, right, and deployment. It will typically require cabling, it will require servers. So that's something which sometimes you cannot afford or does not fit your business case, right? Second disadvantage is, what if then you have a very nice scanning environment, real time in your factory, but sometimes this asset, the thing that you are tracking, moves outside or moves to another supplier, and then you have zero visibility.
Okay.
The solution could be, of course, well, we equip two kinds of trackers, but then you need to merge a lot of information sources again. But here with Sensolus, we actually have a very unique system where we can enable one of our trackers to emit Bluetooth in a certain format, so that it is also discoverable by the Coupa location technology. So Coupa is a provider of a Bluetooth-based high-precision indoor location system, which can provide sub-meter accuracy, again with the, let's say, known concerns that I just mentioned, being it has a certain installation cost much higher than, as I mentioned before, the light infrastructure installation cost of a geobeacon, right? But again, more precise in space and time.
Okay.
But when we enable this, then you actually have the best of both worlds, right? When it is outside, when it is with a supplier, it uses the location technologies of the tracker. But when it is then discoverable by the Coupa location system, inside you have the 1 meter precision, or depending on your installation, can be a bit better or a bit worse than the 1 meter. So this is actually the best of both worlds, and that's a very unique thing to have. So actually a great feature.
Okay, nice. And how do I need to think about this Coupa thing? Is it like placing antennas in the building?
Exactly, yeah. So it's placing antennas. You could call it like satellites, inside.
Okay.
But the communication works a bit different. So this is also emitting a signal, and the locators of the Coupa system, which typically deploy on a ceiling,
Okay.
they use angle of arrival, and they triangulate based on the angle of arrival. They will triangulate position. So it actually will do continuous measurements and know then where the tracker is. And also important is, because we have a accelerometer in this tracker, when the tracker is being moved, it will advertise a signal at a very high frequency, at a stronger frequency, because then you have better accuracy. But then when the asset is standing still, it's not moving anymore, and then it will reduce the frequency because if it's standing still, you don't need to update, which gives the benefit that you have better battery saving. You have a better battery life on your tracker.
And does this Coupa combination have a big impact on the battery autonomy of your tracker?
No, actually not at all, because Bluetooth advertising, which is the technology being used, emitting Bluetooth low energy does not cost that much. And as I just said before, especially if you reduce the advertising frequency when it's standing still, you actually have a very low energy cost, right? Because typically, taken over a day or a week, assets are mostly standing still and occasionally are moved.
All right. Okay. Thank you. So thank you for watching. If you want to see more videos, there's a link in the description, and we'll hope to see you there.